This video covers National 5 Chemistry calculation questions. Specifically, we're going to look at specific heat capacity, so EH equals Cm delta T. A good place to start is looking at this worked example. So calculate the temperature when 100 grams of water is heated using 8.36 kilojoules of energy. The equation here we're using is this one here, so EH equals Cm delta T. If you go to your data booklet, it is at the very front of the data booklet. It is here. So EH equals Cm delta T. So this looks like it's got lots and lots of parts to it, but actually it's seductively simple. So here down here, it tells us that the C is pretty much always 4.18 kilojoules. So if they give you answer in joules, or if they give you information in joules, you have to convert to kilojoules per kilogram. So this is for us a kilogram of water, and it's per kilogram per degree C. So for 1 degree C, this would be correct for 1 kilogram. So EH equals 4.18 times the mass of water multiplied by the change in temperature, which is what delta T is. The questions can ask you to rearrange this to any way, so they can give you, in this case, E, and they can give you EH, and they can give you the mass of water. You can assume that 4.18 is the specific heat capacity, and then you can have to rearrange it to find delta T. So here we go. In this case, EH is 8.36, and they've given us in kilojoules rather than joules, so that's useful. We can just leave it as it is. Specific heat capacity is 4.18 kilojoules per degree. The mass is 0.1 because we want the mass in kilograms. They've given it us in grams, so it's 0.1. We don't know the delta T. That is what we're... Obviously, if they gave us delta T, this would be a really easy question because that would be the answer. But 8.36 is 4.18 multiplied by 0.1 multiplied by delta T. So 0.1 is a tenth, so you might already know that what you're basically doing is 8.36 equals 0.418 multiplied by delta T. So that's what we have here. Divide both sides then by 0.418, because what they're basically saying is 8.36 is the delta T multiplied by 0.418. So it's a 0.418 of this. So if you divide both sides by 0.418, you'll end up with 20 equals the delta T. So that's the change in temperature. It's 20 degrees C. Making sure we always put the units in where we have these things. So if we've got energy, you want it in kilojoules, mass, you want it in kilograms, and temperature you want in degrees C. So we'll rattle through some more of these examples. When 5 grams of fuel is burned, so that is a complete red herring. We don't care how much fuel they're burning, really, most of the time. In this case, we funnily enough do. 150 kilojoules of energy was released. Calculate the energy that would be released if 60 grams was burned. So the interesting thing about working backwards in time is we start at the present day, where they assume you can already do the standard question, and they try and make the question a little bit more tricky. So what they're saying here is that if you burn 5 grams, you get 150 kilojoules. If you burn 60 grams, how much will you get? Well, 60 is more than 5, but we're thinking, well, how many times more than 5 is it? So we'll work it out. So 60 divided by 5, that looks like that's going to be 12. So it's 12 times bigger. So you'll get 12 times more energy, theoretically, if you burn 12 times more. So if you multiply 150 by 12, you get 1,800 kilojoules. And again, it's important to put the units in. Calculate the average energy absorbed by water using the data below and the experimental setup. So the average change in water, 20 plus 20 plus 23. So that's 63 divided by 3, which you would imagine is probably 21. So the average change in temperature is 21. It looks like, so the delta T, change in temperature, is 21 degrees C. It looks like it's 0.1 kilograms of water. So it's going to be 21 times 0.1. So we're thinking probably at the moment it's 2.1 multiplied by our specific heat capacity. So they haven't told us we're not using water. In fact, they've told us we are. So you're going to be multiplying, we're at 2.1 by 4.18. So if you do that, you end up with 8.8 kilojoules. And which of the following is most energy absorbed? So we are assuming that specific heat capacity doesn't change, so we can actually just completely ignore it from this here. It's the mass multiplied by the temperature change. So the mass in kilograms, we do 0.05 multiplied by 10, which is 0.5. 0.05 multiplied by 20, which is twice as big. So instead of being 0.5, we're probably looking at 1. So this number is now the winner so far. 0.25 multiplied by 8, so that I think is 2. So C is currently winning. But 0.25 multiplied by, well, a bigger number is going to give a bigger number. So the answer is D. I'm going to be too cowardly to actually just try and work that out off the top of my head, but it's a quarter of 18, which is 4 point something, 4.5 or something. So calculate the energy in kilojoules absorbed by the water in this experiment. So we don't really care about how much isopentane they burned. That's why quite often it's a red herring. It's just not just now. The mass of water they heated is 0.2 kilograms, because it's 200 grams. So 0.2 multiplied by the specific heat capacity, which is 4.18, okay, multiplied by the change in temperature of the water. So that is 12 degrees C. So it'll be 0.2 multiplied by 12 multiplied by 4.18 gives us 10 kilojoules. Calculate the energy absorbed by the water in this experiment. So again, it's nice and simple. We trot out the same exact thing. If you did the exam in 2023 and had practiced the 2022 question, you'd be in luck because a very similar one came up. We don't care about the mass of the crisps. We do care about the mass of water. So that is 0.01 kilograms multiplied by a change in temperature of 15. So 0.01 multiplied by 15 multiplied by the specific heat capacity gives us 0.63 kilojoules. So that's all the ones we've got here. We've only gone back as far as 2022, but I think it's quite sufficient. We see what we're doing here. We're just filling our numbers into our equation. If you've got any questions on that, please do get in touch with your teacher.